Today, guys, we're gonna start in a new chapter. So we're gonna pass to chapter 20 after we already done of chapter 19, and we studied what is the electricity, what is static electricity, and then electric current, and we know the parts of electric circuit, different types of electric circuit, and the difference between parallel and series electric circuit, and all these. Now we're gonna pass to another chapter, which is talking about the magnetism and electricity. So we're gonna talk about the relation between the magnetic force and the electric force, and talking about how we could use electricity to make a magnet, and the vice versa, how we could use a current, okay, or how we could produce a current by using a magnet. So actually, we're gonna start directly from lesson 2. So we are in chapter 20, lesson 2. Okay. So here, this one, making a magnet with an electric current. So that is a very big question here. Okay. So first of all, before we start, okay, we need to know what is magnet. Anyone know what is a magnet? In your own words. Yes, Ana Hamdi.
It attracts metal, for example, or
Yep, metal, all the metals.
no.
Well, so what it attracts?
Um.
Iron.
um
Okay. So
okay.
good. So actually, magnet. Once we said what is magnet, so actual magnet, it's a material. It's already found in nature. We discovered magnet in nature. Okay, this material has ability to attract certain elements like iron, cobalt, and nickel. Only the three elements. So we call them. They are magnetic material. So the magnet is a material that could attract the three metals. Okay. So once we discover the magnet, okay, we start to study the magnet, what is a magnet, how it's attracted, what it's made up of, and then we start to make even artificial magnets and so on. During the study of the magnet, we discovered that there is a kind of relation between the electric force and the magnetic force, or there's a kind of they are look like two sides of one coin, okay, electricity and magnetism. So in that lesson, we're gonna reflect, or we're gonna show this kind of relation between the magnetic force and the electric force, or between electricity and magnetism. So by the end of this lesson, we should be able to answer the following question: why does a magnet apply force on an electric current? Then how do electromagnets and the permanent magnets differ? And finally, how do electric motor use magnets? Okay. So let's start by the new vocabulary which you're gonna learn: electromagnet, electric motor. Okay, so let's start here. Actually, this the idea or the relation between the electricity and the magnetism started by a scientist. His name is Faraday. Actually, Faraday make experiments on magnets and current and electricity for many years. Okay, and he did a lot of experiments that lead to many important conclusions and observations. So what he observed, the first thing, okay, so you could observe here, okay, that the first thing he did, so he get an electric circuit, normal electric circuit as we know, okay, and we find, okay, this electric circuit is just connected as here to the bulb, as you can see. So what would happen once we make a circuit like this? Just tell me. Okay, tell me, guys, what would happen when we make a circuit like this? Guys, just one only know the answer. What about the others? Guys, share. When we make a circuit
Oh,
like this, what
Mister,
would
who are
happen?
you sharing the screen?
What?
Are you sharing screen?
I can't hear you.
Are you sharing the screen? Well, no.
Yes, I'm sharing the screen. You can see the screen, guys?
Yeah, I think I have that problem.
Okay. You can see the screen like that right now, Lorena?
Oh no, but can I join from another device?
Okay, yes, of course.
Okay.
So others, please, you just tell me what would happen when we make a circle like this, guys. So what would happen? Yes, Hannah Hamdi?
The light bulb will,
The light,
light
yeah, the bulb will light. Why the bulb light? Because there is a
because
current will flow.
yeah.
Yes. So the electric current will flow from the negative terminal to the positive terminal. So as the current flow, it makes the light bulbs. That's clear. So for Dye, while he's making his experiment, he observed something. He placed a compass. Do you know what's compass? Okay. The compass, this one which you refer to the north direction. You know the compass?
Yes.
Yep. So actually, the compass needle, actually, it's a very thin magnet. It's already a magnet. So he observed it when he placed a compass beside an electric current, the needle of the compass deflects. That means the needle of the compass start to move away, okay? So it start to refer to this direction, okay? So he start to remove it away. So he find that the needle returned to its original position. Then put it beside the current, he find that it deflects. So he figured out, okay, as the current flow in a wire, okay, it causes the deflection of the magnet. So imagine if you have a magnet like this. How could you make this magnet move without touching it? Think, guys, please, and share. For example, we have this magnet.
ريبل لازم يحصل ريبل يعني.
So you're supposed to put another magnet beside, yes?
Yes.
Yeah, so we're gonna get another magnet, okay? Put two similar poles beside each other so they will repel. So this magnet will move, yes or no?
Yes.
So Faraday, because he know this already, he figured out as a current flow in the wire, the current has an effect like a magnet because it caused the other magnet or the magnetic needle of the compass to deflect. Yes or no? You got this, guys?
Yes.
Yeah. So he discovered that once the current flow in a wire, this current will have a magnetic field. It has an area in which it represents a magnetic force like a magnet, okay? And this magnetic force could affect the compass needle, okay? Because it's already a magnet, cause it to deflect or cause it to repel away from it. So here like this, realize that any electric current has a magnetic field, okay? So, and he to prove this idea or to prove he made another experiment. What the other experiment he did? So he said that in a current carrying wire, that means once there is a current flowing in a wire, this current will have a magnetic field around it. To prove this idea, he made this little experiment. Okay, he already get a battery and connected with a wire like this. Okay, so suppose that the current will flow in this wire. So, and they start to place the wire between the two poles of a magnet. He observed that the wire keep, okay, vibrating, keep moving up and down because it's actually gonna be the magnetic field that's around the wire because of the electric current will be affected by the magnet. You get the idea, guys? That means it will repel and attract, so it keep moving like this. You get the idea here, guys?
Yes.
Yes. So what we could understood from this that once the current flow in a wire, okay, or once there's an electric current, this electric current has a magnetic field. Any hard question here?
Oh, thank you.
Yeah, okay. So of course, once we open the switch or remove, okay, one wire from the boot, we find there is no effect at all. So that means that the magnet does not affect the wire, but affect the current that flow in the wire. Is it clear here, guys?
Yes.
That's why we said that because negatively charged electrons are moving in a current carrying wire, so the magnets apply force, okay, because already this current, okay, the flow of electrons in a wire make an electric field surround the wire, so this magnetic field could be affected by the magnetic field of the permanent magnet which we use here, okay. You know, heard the question or something is not clear, guys, regarding to what we said. If you have any question or something is not clear, don't skip it, just pause me and ask. Any question, guys?
No, Mr. Thank you.
Okay. So then here, guys, we find once we trying to discover that the electric current has a magnetic field, they start to think, could we use the electric current to make a magnet, or could we use any technique just to use this magnetic field to be more powerful so we could use it as a magnet? That's which pushed the science to discover or to make something with the electromagnet. Okay, so what is electromagnet? From its name, electromagnet. So it's somehow a magnet that works by
Electricity.
electricity. Good. Okay, so that means it's a magnet that created or just made, okay, or works by the electricity. So how we could make an electromagnet? Simply, okay, or that's very easy way to make an electromagnet. First of all, we need a ferromagnetic core. What meaning a ferromagnetic core? That means we need a iron nail, for example, or a piece of iron, okay, So that is a ferromagnetic. Ferro, that means iron. Magnetic, that means could be attracted to a magnet. So like for example, an iron nail. So let's draw it here. Once I get the iron nail like this, sorry. So we get this iron nail, okay? Then we get a wire, and just let's make it in another color. Yep, okay. And then we start to coil the wire around the nail like this. Get a wire and coil around the nail. Okay. Then we're gonna connect the two ends of the wire to a battery. Okay, electric source. So what would happen here, once we just make like this, the current will start to flow. And as the current flow, okay, in the wire, because we make these coils, we make the current is concentrated, that means the current will keep a long time around the nail because it moves in coil. So the magnetic field of the current will cause the iron atoms to be arranged in certain way, so this iron nail will turn to be a magnet, and we could observe that it easily attract other objects. Okay, is it clear here, guys? Guys,
Mr. Noah, can you repeat this part again?
yes, again, how could you make, okay, you can try this at home, or you can make it even at home. So how you could make an electromagnet? Simply, electromagnet can be made, just get a ferromagnetic core. Ferromagnet, what mean by ferromagnetic? We said that ferromagnetic, that means it's a material made of iron, and that can be attracted to a magnet. Like for example, iron nail in your home, you could find that iron nail easily be attracted to a magnet. So it's a ferromagnetic material. So we get, for example, this iron nail. This is the one which is in red color. Then we are gonna get a wire, okay, thin wire, and coil the wire around the nail, many coils, as you can see here, just around it, okay. Twist the wire around the nail. Then we connect it to a battery. So what will happen once we connect it to the battery? The electrons will start to flow from the negative terminal toward the positive terminal. So the current will flow. And as we just explained in the previous slide, that the electric current has a magnetic field. Yes or no?
Yes.
So the magnetic field of the current will make the atoms of the iron nail to rearrange, to just sit in a certain way, okay, in certain orientation, which make this iron nail turn to be a magnet, okay. So like this, we
Okay.
call this, it's electromagnet. Now this magnet could attract other, for example, small nails or paper clips or something like this could be attracted to it, okay, because it become a magnet. Once you remove the battery, okay, or you cut the wire, okay, this nail will lose its ability, will lose its magnetism. It will not be a magnet anymore. Why? Because the current cannot flow, so the magnetic field of the current will not affect the nail, so the nail returns back as it was before. You get the idea?
Yes, thank you.
Is it clear for everyone, guys? Guys, is that clear? Other
Yes.
people, please, okay? So you just respond to me once I take your absence. That means your mics are working and you can hear me. So once I speak to you, please answer, okay? So is it clear for everyone?
Yes.
Okay.
Yes.
Yes.
So here, then we pass to the next part. That's how it's look like here. So that's, we already explained the same as we said, as the current already flow in a wire. So you could find that the current has a magnetic field, okay, or this current has a magnetic field. So the idea here that we are gonna focus this magnetic field around a ferromagnetic core, like the nail, for example, or this piece of iron. So once the current are twisted, okay, or the wire is twisted around the cord, so the current will be focused around this iron core. So the magnetic field of the current, okay, will cause this iron core to change into a magnet. So we call this electromagnet, okay. So my question here, guys, let's try to think together. This electromagnet, how you can make this electromagnet more powerful? How can you make this electromagnet more powerful, guys? Think if I need it to be more powerful.
هعلي الفولتج او current بتاع
Yep,
الباتري.
okay, so we can change the voltage. If we use a battery with higher voltage, of course, the battery with high voltage will produce more current, so it will make it, okay, stronger. Good, that's one point. So increasing the voltage or using more powerful electric source. Good, what else? What do you think?
Adding more turns.
Yes,
of the coil.
good. Increasing the number of loops of the coil, okay? Once you make it more, that means you focus or you concentrate the current more around it. So the more turns of the coil, that means the stronger the electromagnet is, okay? So you are brilliant, guys, okay? You could predict or you could find this out with your own mind, okay? Here, so like this, we said that the magnetic field around the electromagnet can be turned off by turning or removing the current or removing the battery, as we said. Then, as you predicted here, guys, the strength of the electromagnet can be strengthened by increasing the number of loops in the wire coil or by increasing the electric current in the coil. Increasing the electric current, it means using more powerful electric source. That means using more voltage, as Yusuf said. So, any hard question till that point, guys?
Nothing.
Is it anything's not clear? Okay.
No.
So who can tell me how we can make an electromagnet one more time? Yes, Rashwan, you want to ask something?
Yes, Mr. هو احنا can we increase the magnetic field?
Can we that the more the yes, but as I said, okay, as the electromagnet become more powerful, that means its magnetic field become bigger.
Oh, okay.
That means what make or what is the difference between a weak magnet and a strong magnet? The strong magnet, it's a magnet that has a bigger magnetic field, so it could attract objects from far distant rather than the weak one. Clear, Ashwan?
Yes, thank you.
Okay. So who again, guys? Who can tell me how we could make an electromagnet one more time? Who can tell me? Okay. Yes. Just Rashwan and Hamdi. What about the others, guys? Fadia, Hala, Hana Durgan, Kinsey. Please wake up, guys, and share us. Guys. Kinsey, could you help us here? Can you hear me?
Can you say the question again?
Again, tell me just how can you make an electromagnet? Okay, in your home, for example, how you can make an electromagnet?
Mr. Can I say?
Just wait for Kinsey, okay? She's gonna answer, I know. Look here, and you can tell me. Okay, Reem?
Mr. Can
Yep.
we
Yes,
create
Kinsey.
by the wrapping wire
Yes, wrapping wire around.
around the iron nail
Yes, good. Wrapping wire around iron nail. Then connect this wire to
to the battery?
yes, to the battery electric. So that's it. Okay. In that case, we are gonna have an electromagnet. Why? Because the current wants it to flow out from the battery through the wire, the wrapped wire around the coil, around this iron nail. The magnetic field of the wire or the current will make the magnetic nail change to be a magnet. Okay.
مستر
Yes. Yes, Yusuf.
مش المفروض يا مستر يعني الايون ماجنت صح؟
Yep.
الكتروماجنت، فالمفروض يحصل يعني المفروض يبقى ده كيميكال رياكشن عشان الاتومز
No, 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 no. It's
مكانها
not.
اتغير.
No. It's not a chemical reaction. It's a physical change. The atoms of the iron are still the same as they are. Only they were just gonna align in a certain way. They have a certain alignment inside the nail, but no change of their structure.
مش بس لو الارينجمنت اتغير
That
يعمل
don't.
اتوم جديد،
No.
يعمل
Hey.
حاجه
No.
جديده.
No, again, imagine that, for example, okay, you are in the classroom, you are sitting in a circle, then I just forced you to sit in a line. You still are in the same grade, the same class, the same students, but just in different alignment. Okay, you get the idea?
يا سمس
Yeah, no chemical reaction. That means it's still iron. Okay, it's still the same element. No reaction because there is nothing to react with. Okay.
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 Thanks.
So here, like this, we said that imagine in this experiment, as you could find here, once we make the electromagnet now has poles like any magnet, south pole and north pole. Okay. So to just to remember what are the poles of the magnet, they are the area where the most of the magnet force is concentrated. That means the magnet is more powerful at its poles than the middle. Okay. So here the north pole and that the south pole. Imagine here, guys, what would happen if I just switched the wire, switched the terminals? That means make this wire connected to the positive and this wire to the negative. What will happen? Expect, guys, what
Mister,
will
can you
happen?
repeat the question?
Again, here, as we make this, the current will flow in that wire in that direction. Yes or no? Like this until it returns back. Yes or no?
Yes.
That lead the magnet, okay, or that lead the
Yes.
iron core to be a magnet with two poles, north and south, as you can observe on the screen. What would happen if I just switched the battery? That means I make the negative in that side and the positive in that side. Okay, what would happen? Yes, Hannah?
They could repel.
No. That same. It's the same magnet. Look with me, Carol. Let's make another drawing here, okay, to clarify the idea for you. That means I have the same battery, okay, but here that is the positive and that is the negative, okay, and then I connect the wire, okay, like this. Just a minute. Sorry. I can get the wire like that, and here that the magnetic will pull inside. So that will make a magnet. Yes or no? This iron, the one, the red one,
Yes.
that will be an electromagnet. Here, the current flow in that direction. That is the direction of the current flowing. Yes or no? The current keep moving like this, until it move back to the positive terminal. Yes or no?
Yes.
Here, the current will move in the same direction or in opposite direction.
The opposite.
Opposite. So the current will flow like this. Yes or no? So as
Yes.
current flow like this, okay, so what would happen now? This will be magnet, but it will turn the poles. Instead, that will be north, that will be south, and that will be the north. You get the idea, guys?
Yes.
Yes. So that means turning or switching the terminals of the battery, okay, turn the poles of the magnet. You get the idea? Is it clear?
Yes. Yes.
Okay. So here like this, okay, guys, we said that changing the direction of the current, that means just switch the terminals, and instead of making the current flowing from right to left, make it in the opposite. That will make the electromagnet change its magnetic poles, okay, or it has opposite magnetic poles, okay. So actually, what the importance of electromagnet, or why do we need to make an electromagnet? Actually, electromagnet is very, very important because it has a lot of uses for the electromagnet in our daily life. For example, you could find there is an electromagnet that found inside your speakers. Okay, so how that's happened? Actually, this part is the electromagnet, this one which found it, and that is a permanent magnet. Okay, normal magnet. So what happens here regarding to the signal which your speaker received from your cassette or from whatever your computer, whatever the sound source. So this electromagnet, it receives it as electric pulses, okay, which make, okay, this electromagnet, okay, change poles, okay. As it change poles, it will repel and attract with the permanent magnet, which cause a little kind of vibration or cause a vibration because of repulsion, attraction, repulsion, attraction. So it vibrate. With this vibration cause the sound to be produced because we know that sound are produced by vibrations. You get the idea, guys, here?
Yes.
Okay, so that's one of the importance of electromagnets that are used in speakers to produce sound waves. Also, electromagnets are used, for example, to carry heavy objects like carrying the old cars and something like this. Okay, do you know in the factories and some parts which they need to carry heavy iron plugs? So it's easily to use a powerful electromagnets to carry them, okay? And once you disconnect the current, or once you turn off the current, you could leave this object. So the best thing about the electromagnet rather than the permanent magnet, that electromagnet, that you could control its strength, and even you could control its magnetism. You can make it already works, or by turning the current off, okay, it will not work, or turn to piece of metal, okay, without any magnetic force. Is it clear here, guys?
Yes.
Okay. Any hard question for what we said, guys, here?
No,
Yeah.
thank you.
Okay. So that will be our session for today. So today we just explained that how we could use an electric current to make a magnet. Okay. Next time, okay, we're just gonna take an example or another use, okay, of the electric current and the electromagnet, how to make the electric motor and so on. So please study this part very well from your textbook, and if you have any question or something is not clear, you can ask tomorrow, inshallah. Any question before we end our meeting, guys?
No, thank you.
Thank you, guys.